Hello everyone, hello, you welcome to our today's session. On this session we will try to see the first part of this chapter. As you know, the title of this course deals with data structure and algorithm. On this one we will try to see the introduction part. On this part we will try to see the introduction to data structure and algorithms, complexities of an algorithms, especially time and space complexities. Then finally we will try to see an asymptotic notation that we will use to donate or to represent the algorithm analysis. As you know, data structure and algorithm deals with programs. Then already know that what are programs. It can be a program. Sometimes we will call them instructions or programs, or it can be programs. And these are an instructions or a program or an instruction which orders what the hardware is to do. So a program is written in order to solve a problem. Assume we have a problem, then when we need to solve this problem using an instruction, we will develop a program which is to solve that problem or the problem that we have. Example, we can see calculating the summation of three numbers or the summation of any real number. On this one we may have a limitation. Then assume we can consider this one as a problem. That's why we need to develop a calculator which is a machine which uses a program to compute the summation, the product, and the division, and the module, and then blah blah, any other mathematical operations. On this one, to guide what that calculator's mission, we will use a program. Then after installing a program, we can use that machine, the calculator in this case. So in general, a solution for a problem actually consists of two things, two components, two elements. The first one was a way to organize data, because the program, any program or any instruction needs a kind of data, then they must need its own organization. That's why this program needs an organized data. Then way of organizing this data is mandatory. And the second one, the sequence, the procedures, which we will use for solving the problem. And in combination of way of organizing data and the sequence as the most important ones, then on this one, the study which deals with organizing data was named as data structure. That's why the way of organizing data in a computer memory is said to be or named as data structure, whereas the sequence of computational steps that used to solve a problem is named as an algorithm. These are the sequences, the procedures that we will use to solve the problems. So by interrelating or combining both of these terms, these elements, we can build a program as the data structure plus an algorithm. Then this is named as a program or an instruction or a solution for a problem. So therefore a program is nothing but a data structure plus an algorithms. Most of the time, I think we are too much familiar with programs. Now you already know we have a programming language like C++, Java, Python, C#, Visual Studio, and blah blah. We have a number of programming languages which are named as high-level programming language. You know, the machine language is a language that the machine is used to store their everything, their asset, their data in the forms of zeros and ones. That representation was named as machine language. Then every data on the machine was stored in that way. When you come to high-level language, these are a language that we can use to write a code which are in a way of an English-like characters. For example, let me see the Java course, or a kind of C++ course. They have an English character. They're based with an English character. For example, when you say out, that was a character which is named as an English character, and then even that way you can program. You can develop the codes or the programs or the instructions which we will use to solve the problem that we have. Then, having seen this, sometimes we may say the program is good, that's best, or that's not best. Then what are the features that leads us to say a program is good? Here you can see these are the elements. The first one, the program was user friendly. The program can easily used by the users. That's why we call it user friendly. Then that's easy to read and understand, easy to debug, easy to modify, easy to update, modify, and easy to maintain. If these features, these are the features which a program must have. If they have these features, we can call them these programs are a good or best programs. In general, as we have seen on our previous PPT, you can see that you can see from this one, data structure deals with the study of how the data is organized in a computer memory. That deals with organizing our data in the machine's memory. Then, if the data was structured, we can or our algorithms can access that structured data easily or in an efficient manner, and they can retrieve easily and manipulate the data easily. That's why structuring was very important. So data structure is a way of collecting and organizing data in such a way that we can perform operations on these data in an effective manner. Assume a data which is organized was too much easy to retrieve, to manipulate a kind of operations on it. That's why we have to store. We have to organize the data when we are storing on the machine. Then on this one, data organization is very important. We have to organize our data in a manner of different ways. For example, in a manner of linked lists, trees, nodes, which is the stacks, the queues. You see, these are a kind of data structure types, data structuring types. So these are this data structure is used to organize our data in a better way, in a better format. Assume you can see this one. Here you can see this one, I mean, which is a data about something, about this one, this individual. Here is the name of this person and his age and a number of other additional data were there. Then this is an example of unstructured data. Unstructured data, which is a data which is represented in the forms of paragraphs. Then always we would call them. These are a kind of unstructured data. So retrieving a data or manipulating an operation on such kind of organization of data was too much difficult. For example, how we can find the age of this person, then we cannot even find that. You see, we cannot even find that. So what could be the solution? We have to store our data in an organized manner. Then you can say this one, columns and rows. And columns and rows in the in database tables. You see? That would be better. In that way we have to sort our data. Then that's an example of organizing and structuring our data. So data structure deals with this kind of force. So assume we have a problem, and then now our main intention was how we can solve that problem. Imagine when we have a challenge or a problems or any kind of problem, then we will never directly go to starting the code. But we have to do a number of activities. For example, we have to develop the problems abstract. We have to build it. On this one, abstraction was very important. Abstraction deals with modeling the problem. Then, given that of a problem, the first step to solve a problem is obtaining one's own abstract view, or we call it model of the problem. We have to model that problem first. This process of modeling is named as an abstraction. And assume we have this problem, then our main intention, our first step would be must be to model the problem in a good manner, in a best manner. Then when we are doing this one, we will call it abstraction. So on our first activity, we have to develop the abstract view of the problem in total. Then on this one, when we define the abstract view of the problem, we have to clearly understand the data which the problem needs, which needs for the problem. In the same manner, the operation that we have to perform on the data which are applied on the problem. Then in this way we can understand the abstract view of the problem. Most of the time we'll never focus on the detailed ones. When we are developing an abstract view of the problem, we have to focus on the major aspects. So that's why example, you can see this one. We can take an example. This is an example or a problem which deals with employee management of an organization. Then on this one we have to clearly know that the data, the problem stores and employees with the relevant attribute, which is named as data, the data of the employees. In the same manner, we have these operations. This problem environment have such kind of operations: hiring, firing, retrieving, which is displaying an infos of the problems, the institution or the employees of the organization in total. So in any domain when we need to solve a problem, the most important one must be to create the abstract view of the problem first. On this one we have to identify the data which exists on that problem environment, in the same manner the operation that we have to perform on it. So this is what we call an abstraction. Then this is the end of the first portion. See you next.